So we're going to talk in 5.4 about different features of polynomial functions. So here we have a polynomial function. F of x is equal to, x to the 4 minus x cubed, and so on and so forth. Now, just by looking at this, we don't know exactly how this looks, okay? However, we can use a table of values in order to be able to graph it, right? And sort of, sketch a graph for it. Now, when you make a table of values, you should be able to pick points that are going to be useful to you, right? So we always want to pick x equals 0. And then in addition to that, we want to pick some numbers that are negative, and we want to pick some numbers that are positive, okay? Because we really need to look at, this entire function here. Okay, so here we have these functions right here, these numbers right here. So when I plug this in, first of all, this is, f of x like this. When I plug these in, I know you guys know how to do this. So when I plug in -2, I get +9. -1 gives me -1. What's f of 0? 1. And then f of 1 will be -3. F of 2 will be -7. F of 3 will be 19. So this, along with the end behavior, will give me a very good idea of how this graph looks. So let's go ahead and put down our points first of all. At -2, it's 9. -1 is -1. 0, 1. 1, -3. 2, -7. And then 3, +19, which is off the grid, but that's fine. I don't really need to plot that, okay? Another thing I want to look for is the leading term and look for the end behavior, okay? So the end behavior, this is even exponent, positive coefficient. You can take notes on paper. That means the end behavior will be at, to the left and to the right. The graph will be going up to positive infinity, right? So positive infinity, positive infinity. That means, this graph will cross the x-axis. Oh my God, it's so slippery. Here. It has to go back up for this, come back down, further down, and then it has to go back up because at x equals 3, it was +19. So all the way up like that. So do you see how there is really no other way for this to look than this, okay? So some points along with the end behavior gives us a really good idea. Now you're probably going to ask, how do I know how high to make, how high or how low to make this maximum minimum? You really don't, okay? But we do know that, like, it has to turn around in order to get to the other point, turn around to get to the other point, and so on, okay? All right. Now, location principle. This is something that we've talked about before. As you can see here, there are 1, 2, 3, 4 roots, but they're not integer values, right? However, we can estimate them by looking at the two values in between, between which f of x changes from positive to negative and negative to positive. We've done this before, right? Right? So take a look here. F of x is +9 and then switches to -11. So I know that, there is a 0 between -2 and -1, right? So look at this question. It's asking for the function in example 1, identify between which pairs of integer values are the roots found. So I have one between -2 and -1. I have another one between, let's see, here, -1 and 0, right? The y values change between negative and positive. So from -1 and 0. Where else is there a change between positive and negative? 0 and 1. And between what? 2 and 3. Okay? Huh? Here, look at the table and guys, look up here for a minute. Look at the table and look at where the y values change from positive to negative. That happens between x equals -2 and -1. Here it changes between negative and positive, between -1 and 0, and so on. Okay? Now, you can also, on your calculator, you can also create a table to do this. So go ahead and take out your calculators. Okay? And let's graph this. Okay, you two need to stop talking. Let's graph this for a minute. So, okay, go ahead and graph this quickly. So we have x to the 4 minus x cubed minus 4x squared plus 1. Okay? Do you see that? Okay, now, okay, take a look up here for a minute. Once you have this graphed, look at what you can do. Everybody look up here. So we're going to press Control, okay, and we're going to press T. That gives you a table right over here. So you can also scroll up and down in this table and see, for example, okay, look, the y values are positive, positive, positive. Here it changes into negative. Here it changes into positive, back to negative, and so on. Control T for table. Now, you're like, you know what? This table is so overrated. I need to get rid of it. Guess what you do? Control T. And it gets rid of it for you. Okay? All right. Okay, so relative maximum and relative minimum. So, relative maximum and relative minimum are maximum and minimum points that are found within a specific region, not over the whole region. So, for example, if I was just looking at, one part of the graph, and there is a maximum or a minimum, these are going to be called relative max and relative min. So, take a look here. There is a relative minimum located at point B, right here. Because at that point, the graph changes from decreasing to increasing. And this is how we define minimum or maximum. Like formally in calculus, when somebody asks you, hey, what is a minimum? It's a point where the graph changes from increasing to decreasing. Okay? Or sorry, it's a graph where it changes from decreasing to increasing. And there is a maximum at point A because it changes from increasing to decreasing. Okay? Okay. Now, maximum and minimum points are also called extrema. That's like an umbrella term, extrema. Okay? Maximum and minimum. They're also called turning points because at that point the graph literally turns around. Okay? Now, if a function has a degree of n, the graph has at most n minus 1 turning points. Okay, so look, if this has a degree of 5, if something has a degree of 5, it could have at most 4 turning points. All right? Okay, so let's go back to example 1, and we want to find the x-coordinate where there is a relative minimum. So where is there a relative minimum? Right here. What is the x-coordinate? About -1. So x is about -1. Oh, no, sorry. That was for the maximum, right? Sorry, the minimum, that should be here. X is about -1. So where is there a maximum? Right here, about x equals. Lily, are you okay? You want to go get some water? So about x is 0. Okay? Okay, so let's go ahead and graph this next function. Tab here. So it's going to be 2x cubed. So 2x to the power of 3 plus x squared minus 4x. All right, let me see. What a rookie mistake. You know, you could do Control X and Control V, right? Okay, right? And so now we need to be able to find, it says, the coordinates at which the maxima and the minima occur, right? So there is a maximum right here. So we're going to do menu, analyze graph, maximum. So that's that point. Okay, and it says, so here. So it says to estimate the x coordinates where this happens. So now we say, okay, there is a relative max at x equals -1. Okay, so and then there is a relative min at x equals, so we're going to do menu, analyze graph, minimum, and it's going to be right here. Right, at 0.67. Now, let's go back here. Take a look up here. Look at me. Look at what it says. It says to round to the nearest hundredth, right? So for this first one where it's x equals -1, let's go ahead and put 0.00. Okay, you guys okay with this? I don't think we need another example, right? Everybody okay with this? We can move on, I think. Okay, let's take a look at this function. Sketch the graph of a polynomial function with the following characteristics. We want an even function with zeros at -2, -1, 3, and 5. So why don't we go ahead and put the zeros first, -2, 1, 3, and 5. Now, if I want an even function, that means at the left and the right, they're either both going to be going up to positive infinity or down to negative infinity. Now, we don't have any information that tells us whether it'll be positive or negative infinity, so you can choose, okay? Suppose, we pretend it's positive, so, it'll be, like this, going back up, going back down, and back up, okay? You could have totally made them, go back down. That would have been okay too, okay? If it said an even function with a negative leading coefficient, then you knew to make it face down, right? Okay. Next one is a 5-degree function with zeros at -4, -1, and 3. Oops, 3. And a maximum at x equals -2. So at x equals -2, there is a little bit of a not a little bit, but there is a maximum. Now, we don't know how high that maximum goes. You can just estimate. Now, if it's a 5-degree function, how many turning points is it allowed to have? 4 turning points. So there is a maximum at x equals -2. That means it's got to look like this. Okay? So now, it has to, eventually point that way. But we want to make it have 4 total turning points, right? So what I want to do here is create another turning point. That's 2, 3, and 4. Okay? All right? You can estimate them. Okay? So if I didn't have those turning points there, it would look like a 3rd degree function. So how would I, make the difference between a 3rd degree and a 5 degree, right? Because like a 3rd degree function could have also looked like this with only 2 turning points. But I added a few more turning points in order to make it a degree of 5. Am I making sense? Sometimes I make sense to myself, but not to other people. Which one of those times? Let's see. Because it has, like we said here, n minus 1 turning points. Okay? Yeah. Okay. So, annual sales of televisions can be modeled by this function. Right here. Okay? Whoops. So this is the function where x is the number of years after 1995. F of x is annual sales in millions. So first it says to graph the function for x between 0 to 10. Let's go ahead and graph this function. So let me clear this. I'm just going to do doc B very quickly. And I'm going to type in this function. So 0.48. Okay, let's go ahead and do this quickly. Minus 49x. Okay, let's graph this. Now, it says to graph it for x between 0 to 10. So I don't see anything, and I don't expect to either, right? Because this is, sales, and it's not going to be less than 6, right? Even if it's in millions. So first of all, menu, window zoom, window settings. We're going to make the x-min 0. We're going to make the x-min, what? 10, because it says to graph from 0 to 10. Now, what does my x-axis physically represent here, the independent variable? What does it physically represent? What quantity? Years after 1995. What does the y-axis represent? Sales in millions. So how do we know how high to make this, right? So we're going to go tab, tab, tab to 0. Okay, so it goes from 0 sales to, okay, take a look at this function. You see how the end, that constant is positive 599? That means your graph is hundreds up from 0. So why don't I just eyeball and go to 800? Okay, don't go so close. Give it a little bit of a space. I'm just throwing out a number because I don't want to make it too close to 600. Enter. Okay? All right. So turning points of the graph. How many turning points are there? 3 turning points. What? Right, but did you raise your hand to ask your question? It does have a degree of 4. But how many turning points is it allowed to have? Up to 3, because it's got to be 1 less. Okay? So it's got 3 turning points. Okay, now, what about the end behavior? So as x approaches infinity, f of x approaches where? Positive infinity. As x approaches negative infinity, f of x approaches where? Positive infinity. Okay, now, then it says analyze the graph for values x is greater than or equal to 10. Is it reasonable that this trend will continue indefinitely? So there are a couple ways to do this. Why don't we go to Zoom again? I'm sorry, menu, Windows Zoom. Why don't we go to Windows settings, and why don't we go to, like, I don't know, 50 years after? Okay? Look at this. Look at how it's just like shooting up all of a sudden. Is this a reasonable thing for it to happen? Okay, mathematically this graph will shoot up, but is it reasonable that, between these 2 years you're going to have an infinite number of TVs that are being sold? I don't know. I don't think so. An infinite number of TVs. I mean, are they going to be selling? Okay, how big is infinity? Like, I don't know. Trillions of trillions. Are they really going to be selling that many TVs? No. So even though the mathematically, the graph says that, this model was based on statistics over the last couple of years, right? Before 1995. So this model is only good for about 10 years. After that, so many things change. The economy will change. There will be new technology. Like, not one company isn't going to be doing all that well on this one model TV, right? So that's why after that, right, these mathematicians now need to come up with another model for this company's sales, right? So it's no, TV sales will not increase infinitely. Okay? All right, so that is section 4. So remember, homework will be due on the 29th because you've got your quiz tomorrow. Yes? All right.